Hi everyone, today I will be explaining how the base current in a bipolar junction transistor or BJT controls its operation. This is essential to understand how BJTs function as amplifiers or switches in electronic circuits. First, let's quickly review the BJT structure. A BJT is made up of 3 layers of semiconductor material: emitter, base, and collector. The two types of BJTs are NPN and PNP transistors, which differ in the arrangement of these layers. The base is very thin compared to the emitter and collector. The emitter injects charge carriers, which is electrons or holes, while the collector collects these carriers. Okay, now the key point is that the base current, which is IB, plays a crucial role in the overall operation of the transistor. In a BJT, the base current is small relative to the collector current, which is IC, yet it controls the much larger collector current. This is a characteristic of BJT that gives them their current amplification property. The collector current, which is IC, is related to the base current, IB, by the current gate, which is beta of the transistor. The relationship is given by IC is equals to beta times IB. Here, a small base current results in a larger collector current. This is what makes BJTs useful for amplification purposes in circuits like audio amplifiers. Next, the operation of a BJT depends on the behavior of the base current and its influence on the charge carriers. We have 3 modes, which is active modes, saturation modes, and cut-off modes. When a small base current is applied, it allows a current to flow from emitter to the collector, and the transistor is said to be in active mode. The BJT amplifies the input signals in this mode. Next, if the base current increases too much, the transistor enters saturation mode, where the transistor acts like a switch, and the collector-emitter voltage drops significantly. And lastly, on the other hand, if there is no base current, the transistor enters cut-off mode, where no current flows from the emitter to the collector, so essentially turning the transistor off. Let's consider an example in a switching application. If the base current, which is IB, is small, then the transistor is in active mode. It allows a larger current to flow from the collector to the emitter. This can be used for amplification or controlling high-power circuits. If the base current is large, the transistor will saturate and the current flow from collector to emitter is maximized, essentially acting as closed switch. In conclusion, the base current in BJT is the critical control element that determines the transistor's operation. By varying the base current, we can control whether the transistor acts as a switch or an amplifier. It allows BJT to perform tasks like signal amplification and electronic switching in a wide range of applications. Thank you.